Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in Module 1 in the exam objectives by discussing Section 1.2. Our topic is Notational Systems. Let's begin.
When we use the term notational system, it's a way for our computers to use certain types of numbers and letters to determine specific values in our IP calculations. The first notational system we will discuss is binary notation. Binary notation is a numerical system that only uses two digits, the numbers 0 and 1. Binary notation is what we call the power of 2, because we are only using two different digits, 0 and 1, in our binary calculations. In binary notation, we are using a unit of measurement called a bit, B-I-T. Bit is short for binary digit. And each individual bit within binary notation will have either a value of 1 or 0. If a bit has a value of 1, we also say that this is a value of true. If a digit has a value of 0, we also say that it has a value of false. We use binary notation in information technology most commonly with our IPv4 addresses. IP stands for Internet Protocol, is the system that we use to give numerical addresses to websites. Within an IPv4 address, you will have 4 different sections of 8 bits. We call each grouping of 8 bits a byte. 1 byte equals 8 bits. You may also hear each grouping of 8 bits referred to as an octet. Now, when you are looking at an IP version 4 address, and we have an example in our course notes, each individual bit will double in potential value as you go through the octet. So your first bit will have a theoretical value of 1, and you will double as you go from the first bit to the 8th. So you double your value from 1, 2, 4, 8, 16, 32, 64, and 128. And in binary notation, each of these individual bits will have a value of either 1 or 0. Any individual bit that will have a value of 1 or true will indicate a value that we will have to add to determine the numerical value of each section within an IPv4 address. But just to remember, each time you have an individual bit that returns a value of 1, you take that value and add up all of the different values that return a true or numerical value of 1. And then when you add all those together, that will give you the numerical value of each individual octet within an IPv4 address. Our next notational system is decimal. And decimal notation is a numerical system we use within our mathematical equations and computing calculations. It is what we call a base 10 numbering system. Within decimal notation, we can use all of the individual numbers or digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. As we calculate decimal notations, we use a reference point called the decimal point. Any value that is to the left of a decimal point will distinguish some type of whole number value. All of our digits that are to the right of a decimal point will be a fraction. With decimal notation, we move from one counting place to the next using the power of 10. So if you're looking at the example in our course notes, when you go from the decimal point going left, every time you go to a different location in the numbering system, you are increasing by power of 10. Your first column will be ones, tens, hundreds, thousands, and so on. To the right, We do the same type of 10 base numbering, but we do so in a way that will display a fraction, a fractional value of a number. Your first column to the right of a decimal point will be tenths. The second is 100ths, thousandths, and so on. We use decimal notation in our mathematical equations, as well as our common computing calculations that we use within our computer and operating systems. The third notational system to understand is hexadecimal. Hexadecimal is the notational system that we use with IP version 6 addresses. IP version 6 is the Internet Protocol version 6. It is the most recent addressing system that we use for websites on our internet networks. With hexadecimal, we have 16 different digit values. We use the same 0 to 9 integers that we use in decimal, but we also use the letters A through F to represent the values of 10 to 15. With hexadecimal, the letter A will equal the value of 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Within an IP version 6 address, each section will contain 16 bits. And we will calculate the values of each different section within an IP version 6 address by using either the 0 through 9 integers or the letters A through F that will correspond to its value between 10 and 15. So just remember the three notational systems we discussed were binary, which is a power of 2 that uses only the numbers 0 and 1. We have decimal notation, which is our most common mathematical numbering system that uses the 10 whole integers 0 through 9. And hexadecimal, which uses the same 0 through 9 integers, but also uses the letters A through F for values 10 through 15.
That will conclude our discussion of Section 1.2 Notational Systems. In our next episode, we will move on to Section 1.3 in the objectives and discuss units of measurement. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.